Welcome to my YouTube channel. So today we will be solving the question that is Code Forces round 977 Division 2 based on Comfest 16 final round. This is C1 question. Adjust the presentation easy version. There are two versions actually for this problem, and in this q equal to 0 is taken. Okay. So let's first understand what is the question. So the question is telling us that there is a team consisting of n members. Okay, 1 to n, and is set to present a slideshow at a large meeting. The slideshow contains m slides. Okay. Now there is an array A of length, and initially the members are standing in line in the order of A1, A2, An from front to back. The slideshow will be presented in order from slide 1 to slide n. Each section will be presented by the member at the front of the line. After each slide is presented, you can move the member at the front of the line to any position in the lineup. Here to note the main thing is after each slide is presented. After, for example, here let's say the array A1, A2, A3 up to An is 3, 1, 2, 4. Now let's say that third member presented slide. Now he can be moved to any place. Okay. Now there is also an array B of length m. The slideshow is good if it's possible to make member bi present slide I for I from 1 to n. This thing is not important for our question as q equal to 0. Let's understand this with an example. 1, 2, 3, 4, 1, 1. So this is our array 1, 2, 3, 4 in A and 1, 1. So this size is having m size and this is having n size. This is how the people or the members are arranged to present the slide. And this B that is 1 and 1 is that what it needs, as here say, for good presentation bi present slide I for I from 1 to n. That bi should present the slide I means this first slide should be presented by 1%. This slide should be presented by 1. This is what it's saying. Means if it's possible to present, then we are done. So now, why the answer for this? Yeah. So the second thing was if you can present, if you go down and see if you present, so output yeah if slideshow is good, and output DIDAK if not. Okay. So yeah, so its output is yeah because here is 1. So, okay, 1 presents this first slide. This is done. Now we go to this one, second one. So 1 should present now. So as we were knowing it after 1, 2, 3, 4, this was first our arrangement. After 1 is presented, you can arrange in which way? Four ways. Like okay, 1, 2, 3, 4, 2, 1, 3, 4. Another is 2, 3, 1, 4. 2, 3, 4, 1. So it's up to us that which arrangement we choose, where we put our 1. As we see in this example, we have been given this operation to do, right? Like 3, 1, 2, 4, 3 can be put here, 3 can be put here, and 3 can be put here, right? Or 3 can be put here. In the same way, the 1 can be put here, here, then here, or here, or here. So as I want that 1 must present here, I would choose this arrangement. Okay. And so I can present this slide also by 1. So I printed here. Now let's understand with the second example, that is 1, 2, 3 and 1, 1, 2, 3. Okay, so the initial arrangement is 1, 2, 3. Now our in which we wanted 2, 3, 3, 2. So 2, 3, 3, 2 in which we wanted. Okay, this size is m. This is br and this is n. So why also here? So see, here was 1. Okay, so 1 was done. Okay. Now I can place 1 in 3 case. 1, 2, 3 first case, 2, 1, 3 in second case, or 2, 3, 1. I choose this one. Okay. So this also is done. Now when the 2 order came, what I will do? Okay, I don't care actually. Okay, so this one should be shifted, right? So you can put 1 here or put 1 here. You have option. So we don't take care of one where we put, we just remove this. Okay. So 2 is done. 2 is done. Okay. Now comes 3. Comes 3. As 2 is done, you remove 2 and put here. So it is something sort of data structure, or you can have a visited thing to say that okay, they are done. They can be in any place after they are removed. We don't take care. Why? We will understand that. See, this was 3, right? This was 3. 3 was here. Done. 3 was here. Done. I don't take care that 2 and 1 are there or not, or where are they. I don't take care. I am just concerned with first one. Okay. Now comes 2. Now, if you see that, if see, if 1 was positioned this one, let's say when 1 was removed, the 1 was positioned here. So will you able to do here 3? No. No. So obviously 1 should be here, right? So after 1 was removed, after we finished here, this was our arrangement, right? Now when 2 was removed, we were into 3 2 1 and what 3 1 2. What should have we chosen? As after 3 we want 2, we would have chosen this arrangement. Now let's say next, okay, next, at the next position after 2, let's say I need 1. Let's say, no, let's make the test cases like it 1 3. Let's see. So 3 2 1 is the case. 1 is there. 1 is there. So 3 was removed from here. After when here 3 was complete, 2 got. Now I actually don't care that where should 3 be present. We would say in the future. 2 done. Okay. Now what? 1 came here. Okay, done. Now when 3 was removed, I should have put in 3 here so that my next 3 is done. What I'm trying to say is that once here, let's copy the example 1 2 3 1 2 3 1 1 2 3 3 2. What I'm trying to tell is that once he is presented, once all have presented, you have option to put anywhere. You have option to put anywhere. To put anywhere. So if there is 1, if there is 3, if there is 2, because once they all are done, once this 1 2 3 are done, like okay, 1 is done, so here 1 is kept aside, 2 is done, 2 is kept aside. Now 1 and 2, they are in different section. This is a bag. Okay, the different types of now array elements which are different from 3, and I can use this 1 and 2 to put it anywhere as I want. So the main thing is that if understand a case, if 1 2 3 if all are done, if at any point of time, if all have presented at least one time, we will print yeah. We will easily print yeah. Okay. Another case, let's see the example where we get data. Let's see it. Okay. So here is, let's say the example is 3 1 4 2. This is our initial arrangement. 3 1 1 2 3 4. 3 1 1 2 3 4. Okay. Here let's say, okay, let's say here 3. I need 3. Okay, this presentation done. I needed 1. As I can remove this 3, put it in a bag or a data structure, or you can represent a thing. I can use it 3 anyway. Means in further case, I find whenever 3 I have not having any worry. Now comes 1. Okay, I found my 1. Wish you very good. 1 done. Here also 1 done. Next come 2. Now as 1 is presented, I will keep it in another bag. But here the issue came after 1, 4 is to be present. But we need what? We need 2. If here was 3, let's say here was 3, will there any issue? Because what I would have done, I would have put this 3 here. But as this 2 is not in this bag, it's not in this bag. Please understand this segregation of elements is very important, because as this 2 is not here and this is not equal to condition, so we can say, okay, it's not possible, we print deduct. Let's take another example using this example only. Okay, so let's say, okay, 3142 was there. Okay, so it was 3142, and instead here is 2. Let's say we swap this 2 and 4. Okay, so what we do is that we put 4 here, we put 2 here, an issue, and let's say we have 1 here. We start, we have a bag, say 3 inserted here, 1 inserted here, 1 done, 1 is here. This 4 and 4 are equal, no issue, as they have presented 1. Now see, you have got 1. What would you have done? You would have put this 1 here. Now I don't care that, okay, 3 was presented where, because they will be arranged in such a way, because I have put this 3 here only, so that 1 was to be put here. So when 3 was gone, the array was looking like this. As I now need what? 1. So I will put 1 here. Then as I need 3, do it. Then I need 2, and put it in the bag. Once all the elements are in the bag, then wait. Now if this was 3 1 1 4 2 3 1 1 1 1, I don't actually care, because then all will take care. Why? Because once you put this 2, because it was 3, you would have put this 3 here, right? Now once this 3 was done, okay, so here was, so it is 4 1 2 3. Okay, sorry, it's not 4 1 2 3, it's actually okay, so 4 1 3 2, and then so it was 4 1 2 3. Now as, okay, so there was 1 3 2, and I actually 4 1 are out here. I don't take care. 2 is gone. Okay, now come 3. What I would have done is 1 should be kept here, and span 4 1 3 2 was there. Okay, there was there. Okay, and let's say 4 was gone. Now 1 was to be shifted here, right? So that when 3 came, this 3 should be put here. Now here, as 2 came, this 2 should be cut down. Then 3 came, and then 1 came. Right? 3 came, 1 came. So once all the elements are here, all the elements are in my bag, all the n elements are in my bag, I actually don't take care. Then all will be done. All things will be done. Another, if I would see an example, let's say you have 2 3 4 1 initial order. Let's say you have initially 3. Now as 2 has not presented initial, I want 3. My bag is initially empty. I can't list 2 anywhere. So I should return deduct, because I can't do 3. Right? And let's say first 3 3 1 4, and this 2 was, let's say this is not 2. Let's say the 2 was here. 3 3 are done. You put it in the bag. Put it back. You need 1. 1 is not in the bag, and also it is 4. No data. So you just need to observe that once all the at least 1 have presented, then we are done. Okay. Let's get to the code and solve this question. This back we have to use set, or we can have a visited array of n elements, which is having boolean value. Boolean value. 0 means it is not in the back, not in back. 1 means in back. Okay. So it's up to you. We will be using visited array thing. Okay. So let's get to the code and see. So here let's take input in n comma q comma m. Say n and q. Q is 0 initially. Now let's take the input for a and b. And similarly we would take the input for what b. Okay. Okay. Now let's have a visited array or bag which is saying that okay, initially it is 0. Okay, and initially the bag is empty. Let's traverse in the slides in which we wanted. Okay, in the b array. Okay, if one thing is that if, and let's say we have a count, or we have a pointer in the a array that we need information. We need at which point we are there in this array. So let's say we denote this pointer with j. Okay, so this j initially it is pointing to this first element. Okay, now see if this a of j equal to what? B of I. And what? Continue. Here if you see, here was 3314 3421 and 3341. This 3 and 3 are same. As 3 is presented, I will put in this back. And since here is j, here is I, that b of I, then both move forward. Here I and here goes j. Right? So continue, and what? This of this a of j minus 1, because it is 0 index, equals 1. If they are not equal, let's say if they are not equal, so the case is that if there was a case that we were actually 31141. So here I think here is a, so here let's say it was 1 and 1. Okay, now you come to 2. So 1 2 3. Okay, so you come to an initial, our bag was what? Our bag is only filled with 1. Okay, filled with 1. So here our bag is only 1, having 1 at this point. Here is our I1. So let's remove this. Okay, and here was our 1 2 3. Here is our, sorry, I1 j here. Okay, sorry, the j is here and I is here. Now they both are not equal. What I will do? I will check if this 2 is present in my bag. It is not present. Okay, so move this j here. Okay, so before moving this j, this 1 should be there, because you can't move like that. Okay, this a of j should be in the bag, so that you can move to 2, because if 1 is not presented only, you can't move this, right? You can't go for checking 2. Okay, so here as b is 1 is in bag, we will go for 2. We will check if 2 is equal to that, right? If they're equal, we're done. So if they're not equal, what we will be doing is that first case, if this of a of j minus 1 equal to 1, then do what? j plus plus, and here do I minus minus. I minus minus to again check for p of I. Else, my friend, if one was not in the bag, if one was, let's say my array was only 2 3 3 2 3 3 1 2 3 3 2 1, and my this my is a b array, and let's say my array was 2 3 1, sorry, it was my 1 2 3 array. Now I needed what, 2. Now initially, my friend, this bag is empty. Initially this bag is empty, right? So so this one, this arrangement of one doesn't satisfy. This one can't be put, or I can't move anywhere else. I need a one here in B. So I print or return deduct. Okay. So I, what I do, I see out deduct, and then and return. Now if all went good, at the end, what I will do? What I will do? I will print what? Okay, see out. Yeah. Right? All went good. And another case, if at any point, if j equal to n, what is this case? This case is telling all have been all n elements are in bag. So then further, what is arrangement? I don't care. So here also I do yeah, and then done. Okay. So this is the code. I think it should work. And if phase of a of j is not there, you can do, and do j plus plus for checking further. Let's run and check if test cases are getting passed. Okay, so there's some issue. Okay, sorry. Okay, so the issue was that I was taking the input in the wrong way, and that's why I was getting a different thing. And this is extra condition which I have put, that if my b of I is already visited, means if that b of I element is already in the bag, then I can do continue. So let's run and check if it's working fine. Okay, so yes, so now it's running fine. Okay, thank you